Good morning, students. Good morning, students. Today we will start our new topic, electric motors. Okay, which is depend on the force which is produced by the placing the electric current carrying conductor inside the magnetic field. Okay, force was developed, which we have determined by the Fleming's left hand rule in the last class. Okay, so on the basis of this principle, that the current carrying conductor when placed in a magnetic field experiences a force, and that force creates a motion and moves in the direction governed by the that that current carrying conductor moves in the direction which is governed by the uh, Fleming's left hand rule. Okay, what is the principle of this electric motor? It is based on the principle that a current carrying conductor when placed in a magnetic field experiences a force and moves in the direction by the Fleming's left hand rule. We will find the direction. Okay, and what is a electric motor? It is a device which converts electrical energy into mechanical energy, and that is the kinetic energy. Okay, there are two kinds of motor based on the type of electricity they consume. Okay, AC motor and DC motor. Here we will discuss a DC motor. The motor in a battery operated toy is a DC motor. Okay, here we are discussing about the construction and working of the DC motor. Okay, what does it consist of? What is the construction of this electric motor? It consists of a rectangular coil ABCD of insulated copper wire. Okay, so it consists of a rectangular coil, and it is placed between the two poles of magnetic field such that the arm AB and CD are perpendicular to the direction of the magnetic field, and the ends of the coils are connected to two halves P and Q of the split ring, and the inner sides of these halves are attached to the axle. Okay, now the external conducting edges of P and Q touch two conducting stationary brushes X and Y. Okay, these are X and Y are two stationary brushes. Now, whenever the current in the coil ABCD enters from the source battery through the conducting brush X and flows back to the battery through Y, notice that the current in arm AB of the coil forms from A to B. In arm CD, it flows from C to D. That is opposite to the direction from AB. On applying Fleming's left-hand rule for the direction of the force on a current-carrying conductor in a magnetic field, we find that the force acting on an arm AB pushes it downwards, while the force acting on arm pushes it upward. Thus, the coil and the axle are mounted free to turn about an axis and rotate anticlockwise. At half rotation, Q makes contact with the brush X, P with brush Y. Therefore, the current in the coil gets reversed, and here in this device the direction of the flow of current through a circuit is called a commutator. Okay, commutator is used in this for reversing the direction of the flow of current, and in this electric motors the split rings acts as a commutator, okay, which reverses the direction of the current, and the reversing of the direction of the current also reverses the direction of the force acting in the two arms AB and CD. Okay, thus the arm AB of the coil that was earlier pushed up is now pushed down. Therefore, the coil and the axle rotate together. Okay, coil and the axle rotate together, half turn in the same clockwise direction. The reversing of the current is repeated at each half rotation, give rise to a continuous rotation of the coil and to the axle, and the electric energy is thus converted into mechanical energy. Okay, commercial motors use this electromagnet in place of permanent magnet. Okay, and large number of turns of the conducting wire in the current carrying coil. Okay, electromagnet is placed in place of permanent magnet in the commercial motors, and the large number of turns of the conducting wire in the current carrying coil. Soft iron core on which coil is wound. The soft iron core on which the coil is wound plus the coils is called an armature. Okay, what is armature? Soft iron core on which the coil is wound and plus the coils is called an armature, and this enhances the power of the motor. So this is the construction and working of the motor. How? By reversing the current using the commutators and split rings brushes, we changes the direction of the current in placed of current carrying conductor ABCD rectangular current carrying coil when placed in the strong magnetic field. Okay, then a force is produced there, and force rotates the coil. Okay, this is the working of the electric motor. Now our next topic is the electromagnetic induction. What is this electromagnetic induction? The phenomenon of production of electromotive force. Okay, the force which we have discussed in the electric motor is the electromotive force across a conductor when placed in changing magnetic fields. By changing the magnetic flux linked with it, it is called the electromagnetic induction. Okay, it is about the it is given by the English physicist Michael Faraday in 1831. Okay, Faraday made an important breakthrough and generate currents to this uh, uh, phenomenon. Okay, he was an English physicist, and he generated electricity in a coil by moving a magnet towards or away from the coil. Okay, he placed a coil and moved a magnet towards and away from the coil, and thus produces the electricity with the help of this phenomenon. That whenever a conductor is placed in the changing magnetic field, by changing the magnetic flux linked with it, it is called the electromagnetic induction. Okay, so there are Faraday's laws of electromagnetic induction. First law of the electromagnetic induction. This is the scientist Michael Faraday, was an experimental physicist. Okay, he had no formal education. He worked in a book binding shop during his early years. He used to read books, and that came from binding. This way, Faraday developed his interest in science. He got an opportunity to listen to some public lectures by Humphrey Davy of Royal Institute. Careful notes of Davy's lectures sent them to Davy. Soon he was made an assistant in Davy's laboratory. Okay, so this is the story of Faraday. He loved science. So current in induced coil in 2 when current in coil 1 is changed. This is the mutual induction. Okay. So what are the three laws of Faraday's laws of electromagnetic induction? There are three laws. First law says the magnetic flux linked with the coil changes, induced EMF is produced. Okay, it is about the induced EMF. Second law says that induced EMF lasts only as long as the change of magnetic flux continues. And third law states that the induced EMF is directly proportional to the time rate change of magnetic flux. Okay. Now the Faraday uses the Fleming right hand rule for determining the direction of the induced current. Okay, here cause of induced current is the change in the magnetic flux. Okay, by increasing the speed of magnet or solenoid, we can change the speed of the current, or by increasing the number of turns in the coil, by increasing the strength of the magnet, we can change the magnitude of the current, induced current. Okay, here we will use the term induced current. Strength of magnetic lines of force cutting the coils changes, or magnetic flux linked with the closed circuit changes, and EMF is induced across the ends of the circuit. Now the Fleming's left hand rule. What is this Fleming's left hand rule? Right hand rule. The direction of the induced current in a straight conductor is given by Fleming's right hand rule. Okay, now we have to stage the right hand such that the forefinger, central finger, and thumb are mutually perpendicular to each other. Then the forefinger indicates the direction of magnetic field, and the middle finger shows the direction of induced current while thumb is showing the direction of the force or the motion. Okay, so this is the Fleming's right hand rule. The induced current is found to be the highest when the direction of motion of the coil is at right angles to the magnetic field. Okay, in this situation we can use a simple rule to know the direction of this induced current, and by this is we can find the direction of the induced current. Okay, so this is all for today. We have studied today the Fleming's right hand rule for determining the current induced current direction. Okay, here in this mutual induction is going on. In this observation, we conclude that a potential difference is induced in the coil 2 whenever the electric current through the coil 1 is changing. Okay, whenever the electric current through the coil 1 is changing, a potential difference is developed at the coil 2. So that is the secondary coil. As the current in the first coil changes, the magnetic field around the secondary coil also changes, and thus the change in magnetic field lines associated with the secondary coil is the cause of induced electric current in it. Okay, This process by which a changing magnetic field in a conductor induces a current in another conductor is called electromagnetic induction. Okay, by changing a magnetic field in a conductor induces a current in another conductor, that is called the electromagnetic induction. And in practice we can induce current in a coil either by moving it in a magnetic field or by changing the magnetic field around it. Okay, we can induce current. Okay, in electromagnetic induction shows that, given by Faraday, shows that induced current in a coil can be produced either by moving it in a magnetic field or by changing the magnetic field around it. It is convenient in most situations to move the coil in a magnetic field. Okay, so this is about the electromagnetic induction, that is the Faraday's law, based on the Faraday's law. Okay, and about the working of the electric motor and its construction and working. Okay, thank you. Have a nice day.